Hey, hey, hey! Welcome back, Master Minions. Here we go with a little bit of Geometry Action Chapter 10 for Inscribed Angles. Alright, an inscribed angle is an angle that has a vertex on the circle and whose sides contain chords of the circle. Okay, so here we have that angle right there. It's on, the vertex is on the circle, and then the sides, this is a chord, and the chord is part of that side. Okay, so that is an inscribed circle, QRS. Notice R in the middle there. Next, an intercepted arc is an arc that has endpoints on the sides of an inscribed angle. So the endpoints and the angle lies in the interior of the inscribed angle. Okay, so here we have that arc. The endpoints lie on the sides of the inscribed angle. Okay, that's the inscribed arc. So in this circle, the minor arc QS is intercepted. Okay, so this angle intercepts that arc right there. Okay, now we have three ways. Okay, write these down. Three ways that an angle can be inscribed in a circle. Either it goes through the center, so the center is on one of the sides of the inscribed circle, or the center is inside the inscribed angle, and you can guess the third one. That is, the center P is outside, or is in the exterior of the inscribed angle. Alright, here is Theorem 10.6. That's the inscribed angle theorem. If an angle is inscribed in a circle, then the measure of the angle, this right here, equals 1/2 the measure of its intercepted arc. So this measure right here is half of the arc. Alright, let's use what we know. We want to find the measure P right here. Okay, so we have the arc. That's 70 right there. So pretty easy. Since that measure of the arc of P is half of the arc, then that's half of 70, and so the measure of P is 35. We want to find the measure of the arc PO. So this arc out here. And we know that this is 56. Okay, well it's 2 times. We know that this is half of the arc, so PO is 2 times 56. So we have 112 units of whatever measurement we're using here. Alright, Theorem 10.7. Inscribed angles. If two inscribed angles of a circle intercept the same arc, or congruent arcs, then the angles are congruent. Okay, it doesn't matter where this point falls on the circle down here. If it intercepts the same arc, then these angles are congruent. So C and B are congruent. Okay, so here we have two angles, and they both inscribe this arc right here, SV. So what do we know about these two angles? We know that those two angles are congruent, so I can set 3x minus 5 equal to 2x plus 15, and then solve that way. We get x equals 20. Okay, so if x equals 20, remember I need to plug back in because I'm wanting to find the measure of angle T. So I'm going to plug that back into here. So then 3 times 20 minus 5 gives me 60 minus 5, which is 55. It's the measure of this angle, and U, since it is congruent, is the same angle. Theorem 10.8. Angles of inscribed polygons. An inscribed angle of a triangle intercepts a diameter of a circle if and only if the angle is a right angle. So this right here has to be a right angle. So if we have the diameter as one of the sides of the triangle, no matter where point G lands, it's always a right triangle. Or they could say if FJH, which is the intercepted arc, this is the intercepted arc right here, if that is a semicircle, then the angle of measure G is 90 degrees. Okay, let's use this. We want to find the measure of F. Well, here we have the diameter. So this is the inscribed arc. What do we know about this angle at G? We know that that's a right angle. And a triangle has how many degrees? Think about it. So what do you know about these other two? All right. So we know that all three of these angles added up are 180. And we know that the angle G is 90 right there. So we plug in 90 and the others, we can combine that, subtract, and solve. Divide by 13. We get x is 7. Now if I want to find the measure, I still need to plug that in here for x. So 4 times 7 is 14. 4 times 7 is 28. Plus 2 is 30. Quadrilaterals inscribed in a circle. Theorem 10.9. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. Like L and N are supplementary. It's supposed to be a right angle. So L and N are supplementary, and K and M. So here we have an example. We want to find the measures of A and B. This quadrilateral is inscribed in a circle, and we know that opposite angles are supplementary. So first off, this one's easy. If this is 90 degrees, and these two add to 180, then I know that the measure of A also has to be 90 degrees. Then these other two, we know that these two together add up to 180. So we have 2x minus 30 plus the x down here gives us 180. Solve that, add 30 to each side, divide by 3. X is 70. Now don't stop there. We want the measure of angle B. So we've got to plug 70 in. 70 times 2 minus 30 is 140 minus 30 is 110. And that's how you can use the inscribed angles. That is all for today. Remember to like and subscribe.